Hi, welcome to EROTECH Solutions. So let's see the next feature of microcontroller. So as per now, we discussed about the pin diagram and memory organization, and moving on to timers and counters from microcontroller. So how microcontroller timers works? So this is the common procedure in any microcontroller. So if you have the basic idea about timer functionality and their uses, you can easily understood the next level microcontrollers like ARM controllers, STM32, any microcontroller timers, it is easy to understand. So basically your timers functionality is very clear. Timers are used for delay generation most of the cases, and counters are used for counting external pulses coming from sources like sensors or any button operations. So as per your external pulses counting purpose, you are going to prefer counters. And for accurate time delays, so like you are looking for milliseconds, microseconds, seconds, any exact time delay you want, you need to go with this timers block. As per 8051 microcontroller, which supporting two 16-bit timers, and everything which is measured in bits in controllers, either capacities or sizes or anything, you need to understand what is the meaning of 16-bit timer here. So, and if you observe the regular watch or regular clock, it is easy to understand how it is showing time for us. So which is keep on counting seconds, 1, 2, 3 up to 60. Whenever it is 60 count for seconds, which will increment minutes count, and whenever 60 minutes is over, it will increment your hours value. The same procedure you need to apply here for your timers. But if you want to go with this, you need to know about how timers works and what is the maximum count they are going to count. Okay, so as per capacity, you need to decide that maximum capacity or maximum count. Okay, so timers are also doing the same procedure to give time for us, like just by doing counting process. So what they are counting internally? So timers are counting internally the pulses generated from oscillator. So generally your oscillator is keep on generating clock cycles, and each clock cycle has certain period that purely decided by the crystal oscillator value. What is the supporting frequency or what is the connected frequency with your microcontroller. Okay, but the capacity of timer is very clear, which is counting 0 to 65,535 just in regular manner, 0, 1, 2, 3, 4, and which is reaching 65,535. How I can say that the maximum count is 65,535 here? Because of 16-bit. Suppose your timer have different capacities like 32-bit or 8-bit or 64-bit, you need to evaluate 2 power 64 value or 2 power 32 value. Okay, based on this your timers are going to count their pulses maximum. Then if I am looking for more pulses, again you have to come back, it is overflows from maximum value to 0. 65,535, next count is 0 obviously. It cannot proceed with 65,536, 537, no. So which always overrides with next, it overrides with a 0 after 65,535. So this you need to understand from the timers. So timers are also giving time for us based on counting process, and what they are counting internally, the pulses generated by oscillator. So obviously the pulse period is decided by the crystal frequency. For the pulse period, formula is very clear, 12 divided by crystal frequency. And what is the connected frequency? Which is 11.059 megahertz. Suppose if you are working with other frequencies, you need to apply your frequency in this formula. So now as per this, 12 divided by 11.0592. So obviously I'll get 1 point something, but if you go this megahertz top, it will become microsecond, which means if I count 0 to 1, what is the time period I am getting here? 1.0852 microsecond. So this is fixed, which cannot change from count to count, which cannot change from pulse to pulse. So for each and every count which is giving fixed time for us, like our seconds needle will count one count, the exact time period is 1 second, which is not vary from count to count, right? The same way your timer also doing the same functionality here. But remember, based on the oscillator frequency, you are deciding pulse period. So this is a simple way to understand timers. So timers are used for time delay generation, and how the timers are providing time for us based on the pulses counting process. and this pulses counting, which is maximum 0 to 65,535. If you need more time, then you need to repeat your timers either 2 times or 3 times, depends on your time delay. So now I'll show the one example with this time delay. The time delay I am looking for 100 milliseconds, just suppose. Now what is the number of pulses I need to count? So for that you need to know how many pulses I need to count to get my exact time delay 100 milliseconds as per my application. Now for 100 milliseconds time delay, formula is, number of pulses formula is very clear, required time delay divided by the constant pulse period. So what is your required time delay here? I am just applying here 100 milliseconds, and what is the pulse period? 1.0852 microsecond. So that 1.0852 microsecond, if you cancel with this 100 milliseconds, so you cannot, so I am just converting this 100 milliseconds to microseconds, just multiplying with 1000. So I am getting 92,148.9. So finally your timer cannot count pulses like 1, 1.5, 2, 2.5. No, there is exact count with 0, 1, no 1.5, 1.7 like this. So the timer can count pulses 0, 1, 2, 3 like this only. Okay, so you have to take always the exact count value for your timer. So I am taking 92,149 pulses to count my timer. So but whereas the timer capacity is only 65,535, how can you count 92,148 pulses? So I need to take, suppose I'll tell one example, like you have no only 100 count, but I am saying just count up to 150. Okay, so you need to divide your task into 2 parts, your 1 to 100, and then later I don't know the numbers from after 100. So what I am trying to repeat, I am repeating 1 to 50. So by combining together it will become 150. But now in the case of timers, if you start with 0, there is no chance to stop timer at any middle point. You have the option only for timers just by reaching maximum value. In programming, I'll tell with respect to programming. So in programming you have an option for timer by observing only flag bit. So for timers there is a related flag bit. Whenever timer completes one rotation, the flag bit becomes 1. Based on that flag bit only you can stop your timers. But now you cannot count 0 to 65,535 and again remaining pulses, whatever you have from 65,535 to 929 to 148. So you cannot stop in middle point, so that always in programming purpose you need to evaluate this initial value. So this initial value, which is maintained by the timer related registers TH, TL, which is higher byte and lower byte of timers, because your microcontroller is a 8-bit controller, it cannot process 16-bit value at a time. So again it is divided into 2 8-bits. Okay, so coming to here, I am unable to count 92,148 just by one rotation, so I need to repeat my timer compulsory. So what I am trying to do here, so whereas 46,074 pulses 2 times, so that is the thing I am trying to do here. So I'm just taking this, why I am taking 46,074 here, so I cannot go beyond 65,535 pulses. So whatever the known value, I am trying to count within the limit with the repetitions. Okay, so I am just counting 46,074 pulses 2 times, so obviously I will get 92,148 pulses. So this repetition, if you want to do, your initial value is not 0 here, so I am just subtracting this 65,535 minus 46,074. So if I begin with this 19,461 and I will reach 65,535, how many pulses I counted here? 46,074. So I am repeating this process 2 times. So this is how your timers are working internally for any time delay. Like you are looking for 1 second time delay or 2 seconds time delay or minutes time delay, your timer is capable of counting these pulses. Okay, so now in the next session you will see what is timer and what are the related SFR registers related to timers and how to program timers. Thanks for watching.